Hello students, welcome to Vyas Edification Kota. In this session of NCERT discussion, we are going to deal with the chapter Matrices and the very lovely miscellaneous exercise based on Matrices chapter number 3 of NCERT class 12. That's what we are going to deal with today. Let's discuss this question which says let A is a matrix which is 0, 1, 0, 0. Show that AI plus BA whole power n is equal to a power n I plus n a power n minus 1 times b times a, where I is the identity matrix of order 2 and n belongs to a natural, right? So how do you think we can approach this kind of a question? One of the approaches which the NCERT people love to follow and which they want you to solve using principle of mathematical induction. One of the approaches which they follow is using principle of mathematical induction. So we can discuss this question using principle of mathematical induction, or we can also discuss this question using another approach. What is that approach? Let's take a look at that approach first, and then we'll see the first approach, that is PMI. So the other approach that I'm talking about is when we have two matrices I and A. Now there's a special thing about these two matrices I and A. I and A are two matrices for which the product IA is equal to the product AI. That is, they commute with each other. They are commutative. They follow the commutative law, right? In case of product. Since they follow the commutative law in case of product, we can have very interesting thing over here. AI plus BA, this. Power n can be simplified as a binomial expansion. What do you mean by that? As a binomial expansion, yes. What I'm talking about is this can be expanded very easily. For example, had I had AI plus BA whole square, this could have been written as AI plus BA times AI plus BA. Okay, this is for example, right? So I can multiply them together. This would be A square times I square, okay, plus A B I A plus B A I plus B square A square. This is what you can observe, right? These are the terms that you will obtain by simply applying the distributive law. But observe, this IA will be equal to this AI because the matrix I commutes with the matrix A, and this will become A square I square plus 2AB IA plus B square A square, right? So you may clearly observe that what we have done over here is nothing but just the expansion of this. This is A plus B whole square, and what I have done is this is A square plus 2AB plus B square. I can write it in this form, or you can read x plus y whole square is x square plus 2xy plus y square, right? So the powers, the expansion of powers of such binomials, those results, all of those results hold for this particular kind of an expansion as well. This particular expansion where AI is a matrix, BA is another matrix, right? So such a result holds? Yes, such a result holds. What else? If such matrices commute, then such a result holds. What else is important over here in this question is, if you may observe, this is matrix A, which is 0, 1, 0, 0. The important thing to observe over here is that if I find A square, what do I get? This is 0, 1, 0, 0, A times A. And what is this matrix equal to? Please find this product first. 0 times 0, 1 times 0 will be 0. 0 times 1, 1 times 0 would be 0. 0, 0 times 0, 0 would be this. 0 times this. This is actually the null matrix. This A square is actually equal to 0. And once A square is equal to 0, A power 3 would also be 0. A power 4 will also be 0. A power 5 will also be 0. All powers of A greater than or equal to 2 would be 0 for this particular matrix, right? So this is the given expression in the LHS, and I want to expand this expression using our concepts of algebra. And what I do is, this is NC0 AI power n plus NC1 AI power n minus 1 times BA, plus the next term would be NC2 AI power n minus 2 BA power 2 plus ... There will be plenty of other terms as well. This is the binomial expansion of this. And remember, this whole expansion holds because A and I matrices commute with each other because of that product commutative. Right. So keeping this in mind, once we observe this thing, what do you think? happens to this term? You may observe that a square, this NC2, nothing happens with this. A power n minus 2 is okay. I power anything, I power n minus 2 would be equal to I. Okay, matrix I. B square is okay. What happens to this a square? Observe, in this given question, this a square is actually 0. Okay, and for this given question, this a square is 0. What happens to the next term? In the next term, you'll have a cube, which will be 0. In the next term, you'll have a power 4, which will also be 0. So every term coming after this, that is this term and any further term, will actually be equal to 0, right? You multiply this matrix with anything, that complete matrix would be 0. The matrix that you will get is a null matrix, right? And every other term after this will also be a null matrix. So this here is a 0, and what else remains? NC0 is 1. This is a power n, I power n. I power n is I only, right? Plus NC1 is n, a power n minus 1. I power n minus 1 is I. This is b times a, and what you get over here is a power n I plus n a power n minus 1 b I a would be equal to a. So this expansion is equal to this. A power n times I plus n a power n minus 1 times b times a. This is what you get, and this is what we started with proving, right? This is what we wanted to prove. We have proved that, yes. But this is using ideas of binomial. Okay. Now what do the person want? What do the NCERT people want in this? NCERT people want you to solve using principle of mathematical induction. So if you're only looking for scoring in board examination in such a question, so for writing the solution as per the board examination, what you'll have to do is you'll have to use PMI. So now let's discuss PMI first. What does principle of mathematical induction say? Principle of mathematical induction says that if you want to prove any statement, let Pn, if you want to prove this, so step 1 says for n greater than equal to 1, n belongs to natural. If you want to prove this statement for this is condition for all natural numbers greater than equal to 1, right? Right, for all natural numbers. This number could have started from, let us say, 4, 5, 6 also. So in case the lowest value is 1 over here. So in the first step, what we'll check is whether P1 is true or not. Okay. Since we want to prove this, P1 may come out to be true, right? If P1 comes out to be true, then in the second step, we assume that Pk is true. Assume that Pk is true. In the third step, prove that Pk plus 1 is true. We'll prove that Pk plus 1 is true using this assumption that Pk is true. Okay, those are the steps involved in principle of mathematical induction. Any proof involving principle of mathematical induction will use these steps, right? What is that? That P1 is true, then whenever Pk is true, Pk plus 1 is true. Once you prove this by principle of mathematical induction, you can say that the statement Pn is true. What happens here is actually, since 1 is found to be true on the basis of this result, that Pk is true implies Pk plus 1 is true. P1 will imply P2, P2 will imply P3, P3 will imply P4, P4 will imply P5, and on and on. At the end of the day, you can say that Pn is true for all natural numbers. That's the idea behind principle of mathematical induction. And now let's take a look at this question. Let A equals this matrix. Show that AI plus BA power n is equal to this. So let us call this a statement Pn. Pn is the statement. Let Pn is this statement. What is this statement? AI plus BA power n is equal to A power n I plus n a power n minus 1 BA. This is what you have, right? Okay. So first step that is involved over here is, this is step number 1. What is that? P1. What does P1 say? P1 says that this is AI plus BA power 1, which is equal to what? Can you observe that? A power 1 times I plus 1 is gone, A power 0 is gone, this is BA. And can you observe that AI plus BA power 1 is equal to AI plus BA? P1 is true. So what we note over here is that P1 is true. Okay. That's the first step. What's the next step? Assume Pk is true. Assume Pk is true. That is, what does that imply? Ai plus Ba, instead of n, I have to substitute k. So Ai plus Ba power k is equal to a power ki plus k times a power k minus 1 times Ba. Observe that. Instead of n, I have written k. Instead of n, I have written k at all places. And we have assumed that this is true. Now, on the basis of this, we are supposed to prove step 3. Prove Pk plus 1 is true. That is, what does that imply? Pk plus 1. Instead of n, we have a k plus 1. So, let's replace it. Ai plus Ba power k plus 1 should be equal to, we are supposed to prove this. This is equal to a power n, which is k plus 1 times I plus k plus 1 times a ki power k plus 1 minus 1, which is k times b times a. This is what we have. We are supposed to prove this statement. Okay. For proving this statement, what we can do is we can begin with the LHS, right? Now, our final focus should be on proving this. Let's begin with the LHS. What is the LHS equal to? LHS is Ai plus Ba power k plus 1. Let's separate k and let's separate the other term. Ai plus Ba. Let's write it as this, right? What we have done is we have separated that power of k plus 1 into power k power 1, right? What next? Now, this expression is already known from here. This expression is already known from here. Known from here, yeah, we have assumed that this is true, okay? So, Ai plus Ba whole power k is equal to something. Let's substitute that. What do we have over here is a power ki plus k times a power k minus 1 Ba. This is what is there. And then you have Ai plus Ba again. And then you have Ai plus Ba again, okay? What next? After this, what we are supposed to do is simply simplify this expression by multiplying. Let's do it. So, let's apply the distributive law. This multiplied by this, what will you get? Is a power k, a power k plus 1 times I square, which is equal to I only, right? This is what you get. What next? Let's multiply this with the next one. What you get is a power k times b, Ia would be actually equal to a. The product of matrix I with matrix A is A. What else? This multiplied by this, what you get over here is k is okay. A times a power k minus 1 is a power k. Okay. What else? B times A times I. A times I would be simply A. Right? This is what you get. Is that okay? Yes. What next? What next? The next thing that we get over here is this multiplied by this. And what is this equal to? K times a power k minus 1 b square times a, which is a square over here. Right? That's the last term. Those are the 4 terms that we get. Okay. Now, for this matrix A, over here, a square is equal to 0, 1, 0, 0, which is this, and this product, something which we have discussed some time back, this product is simply equal to 0, 0, 0, 0, that is the null matrix, okay. Since this is a null matrix, this whole overall term would become 0, right. What about the other terms? This will be equal to a power k plus 1 times I, which is okay, plus what else? Let's take out whatever we can common, okay. What do we have over here is a power kb times a. So we can take that out common, we get k plus 1 a power k b a plus the rest. This term would be simply 0. This is what I get. And observe this expression obtained over here and compare this with the RHS over here. A power k plus 1 I, we have a power k plus 1 times I. What is this? A power k, this is k plus 1 times a power k times b times a, and we have that exact same thing over there. Yes, this is equal to RHS. So we wanted to prove pk plus 1, and for proving pk plus 1 is true, we wanted to prove this is equal to this. Okay, and what is this? This is ai plus ba power k, right? We wanted to prove this equals this. And for proving that, have we done that? Yes, this LHS is equal to RHS using this PK. Okay, step 1, 2, 3 done. Therefore, by PMI, we can say that Pn is true for n belongs to natural. For all n belongs to natural numbers, for all natural numbers, this statement Pn is true. That's what we have proved. So this is the idea of proving using principle of mathematical induction. And I hope that makes sense. Yeah, that is all for this question over here.